In this video, we're going to look at derivatives of inverse trig and log functions. So yes, you do need to remember these trig inverse derivatives because you won't be given any formula sheets on any assessment. So try to figure out a pattern in order to memorize these. I usually base off the other ones of sine inverse x. You just notice that cos inverse x has the same derivative as sine inverse x, just with a negative in the front. Tan inverse x is kind of like sine inverse x, except that you don't have a root sign in the bottom, and then your negative becomes positive. And then secant inverse x has an x in the front of the root sign, and you're switching the place of 1 and x squared, and so on. So just try to find some patterns here so you can memorize them a bit better. And we're going to apply these now to actual examples. So in the first example, we're going to find the derivative of sine inverse of x squared. Because we have an x squared, we are going to use the chain rule. So we'll take the derivative of the outside first, which is sine inverse, and now it's going to look like this. Instead of writing just x in here, I'm going to write x squared instead. So 1 over root of 1 minus x squared, and then according to our derivative of sine inverse, we need a squared on the outside, and then we'll take the derivative of x squared, which is 2x according to our power rule. For b, we're going to change this into exponential form because it's in radical form right now. So equivalently, we can change this to the power of 1/5. And then we'll take the derivative. Using the chain rule, the outside function is the power. So we're going to use our power rule first. We're going to bring down the 1 over 5, leave the inside alone, and then subtract 1 from 1 over 5. Next, we want to take the derivative of the inside part, which is 2 minus tan inverse x. The derivative of 2 is 0. The derivative of tan inverse x is just listed up there. And remember to have a negative in the front because this was negative tan inverse x. And then that's it. So go ahead and do those try questions underneath. Again, you're going to use the chain rule for most of these, so please pay attention to that. Okay. So for the next one, for try, you're going to take the derivative of cos inverse x, or in this case, cos inverse of tan x. So you're going to write exactly this, except for x, you put tan x in there instead. And then you'll take the derivative of tan x, which is secant squared x. For d, we'll take the derivative of secant inverse, which is listed above here, right here. So instead of saying x, we're going to say root x because that's what's inside of our secant inverse. And then when we put a root x in here, the root and the squared is going to cancel out. And then after, we need to take the derivative of root x, which is 1/2 x to the negative 1/2. Remember that this can be rewritten as x to the power of 1/2. So when you're doing your power rule, you can just easily throw the 1/2 down and subtract 1 from the exponent. Then lastly, this one is a bit longer. We have a function of a function of a function. So take the derivative of sine first, which is cos. Leave the inside alone. Then we'll take the derivative of cos inverse 2x, which is the one from up here. So that's negative 1 over the root of 1 minus. And remember that is 2x, not just x. We're going to put 2x in the bracket with a squared on the outside, then multiply by the derivative of 2x, which is just 2. Another memorized me, and this has to do with our log functions. So the derivative of log with some base a of x is equal to 1 over x ln a, where a is your base. The derivative of ln x is equal to 1 over x. This one's a very easy one to remember. Okay, so for example 2, let's try to differentiate these functions. Again, we have to consider the chain rule because we have a function of a function. So the first one, we're going to use our log derivative, our log formula. So that's 1 over. In this case, it was x. This case is secant x. So it's whatever on the inside of your log. And then ln of your base, which is 3. Now we're going to take the derivative of the inside function, which is secant x. The derivative of secant x is secant x tan x. And you can easily simplify this because your secant x is going to cancel out top and bottom. We're left with tan x over ln 3. For the next one, for b, the derivative of ln x is 1 over x. So in this case, the derivative ln of cos x is 1 over cos x. And then we'll take the derivative of cos x, which is negative sine x, according to our chain rule. To simplify this, you're going to get negative sine x over cos x, which is the same thing as saying negative tan x. Then lastly, we have ln of ln x, which is going to be 1 over everything on the inside of our first ln. So that's 1 over ln x multiplied by the derivative of ln x, which is 1 over x. And then you could take the derivative of x, but this is just going to be 1, so it's kind of redundant. Overall, this is 1 over x ln x. So go ahead and pause and try those 4 questions underneath, and then when you're ready, press play. So for the first, try it yourself. Ln of 9x, the derivative of ln of 9x, we're going to take the derivative of the ln part first, which is 1 over whatever is on the inside, so 1 over 9x, then take your derivative of 9x, which is 9. Overall, your derivative is 1 over x. And the second one, we'll take 1 over tan e to the x, and then you're going to take the derivative of tan, which is secant squared, okay, and you're going to leave the e to the x alone, and then take the derivative of e to the x, which is still e to the x. For f, when we have a log on the outside, so that's the first function, we're going to differentiate. That's 1 over whatever's on the inside of our log, which is this, and then multiply it by ln, and then our a value in this case is 10, our base is 10. The next part is we're going to differentiate this cos. So the derivative of cos is negative sine, and then you leave the inside alone. Then take the derivative of x minus 2, or x over 2 minus 2. This is also 1/2 x. So when you take the derivative of 1/2 x, it's just a half. Derivative of 2 is just 0. Then lastly, we have log base 3. So we're going to take the derivative of that first, which is 1 over whatever you see in the brackets for the log, and then ln, then your base, which is 3 in this case, multiplied by the derivative of tan inverse. So that's 1 over 1 plus whatever you see in the bracket squared, multiplied by the derivative of 1 minus x, which is just minus 1. And then that's it. Please try to take the time to memorize these. If you need to write them out, please do so. I also have the library derivative available to you so that you have the summary of all of them. You could print this out, and you could also write these on a separate piece of paper to make sure that you have all of these memorized and that you know how to use them.